kind of tell us some special things that could make life a little bit easier. So this one tells us, if we have two inscribed angles of a circle or congruent circles intercept either congruent arcs or the same arc, then the angles will be congruent. Okay, so to make sense of this, if we have two inscribed angles that intercept the same arc or two inscribed angles that intercept congruent arcs, then those angles would be congruent. So let me show you what I mean. When I look at angle 1 in this picture, what arc does it intercept? ST. Okay? When I look at angle 2, stop talking. When I look at angle 2, what arc does angle 2 intercept? Look at, yeah, ST. In order to do it, guys, all you have to do is look at where what it is right in here, and that's ST. And when I did angle 1, that's the same one, right? ST. So this theorem up above tells us that if we have two angles that intercept the same arc, which they do, they both intercept arc ST, then that means these two angles are congruent. So that's what the theorem is telling us. It also says that if these two inscribed angles intercept congruent arcs, which we'll see in a little bit, that they'd also be congruent. So does everybody see that angle 1 and angle 2, they both intercept this arc right here? Okay, so that's how I know they're congruent. Okay, then it tells us in the problem that the measure of arc ST is 68. So measure of arc ST is 68. So let's look at finding angle 1. Would you say the vertex of angle 1 is at the center of the circle, on the circle, out? On. Or what? It's on. So when the angle is on, how do you find it?
Half of the arc.
Half of the arc. So if it's going to be half of the arc, what would it be?
34.
34. Angle 1 would be half of my 68, so it would be 34. Everybody okay with me not showing the work?
Yeah.
So if angle 1's 34, what's angle 2? 34. But I wanted to let you know, if you didn't even know that these two angles were congruent, I could get angle 2. Angle 2 has its vertex on the circle, right? So since the vertex is on, that angle 2 would be half of this as well. And so I could figure out angle 2 by just doing my own math. It's just the theorem is supposed to save some time. So if you know two angles intercept the same arc, then you know the two angles are congruent and you don't have to do double the math. Okay, this next one. It tells us if we have an inscribed angle that intersects a semicircle. So let's look. Here is our inscribed angle, and does it intercept a semicircle? Yes. Then that means this angle is 90 degrees. So that's the value of x, 90 degrees. But if I never knew this theorem even existed, angle x's vertex, is it at the center, on, in, or out? It's on, so if it's on, the angle would be half of the arc. And so how much is this arc?
180.
So if I took half of 180, that would give me my 90 anyway. So the point of the theorem is to save some time, but if you didn't even know the theorem existed, you could still figure out the answers by using those formulas that we talked about yesterday and the day before. Okay? So this is just saying if we have an inscribed angle that intercepts a semicircle, then that angle is 90. Okay, now we're going to go to page 12. I want to do example 9 first, and then I go back to example 8. Maybe we'll do 9 and 10 and then go back to 8. Okay, we have another theorem here, and it's really just meant to save you some time. So it says, if we have a quadrilateral inscribed in a circle, and that's what we have here. This whole quadrilateral is inside the circle, so that is said to be a quadrilateral inscribed in a circle. It says the opposite angles are supplementary. So R and T would be supplementary, Q and S would be supplementary. The whole point of the theorem is just to save some time. Page 12. We went page 13 and then page 12. And I'm at example 9. I'm going to save example 8 for last. Okay, so example 9 says quadrilateral QRST is inscribed in circle C. It says the measure of angle T is 95. Okay, so measure of angle T is 95. It says measure of angle S is 100. So angle S is 100. And then it wants to know the measure of angle Q and the measure of angle R. Okay, So I can do this very easily just using my theorem. So in the theorem it says if you have a quadrilateral inscribed inside of a circle that the opposite angles are supplementary. So if these two are opposite angles and they're supplementary, what's angle Q? 80, just 80, right? Just 80. So angle Q is 80. And if these are opposite angles and they're supplementary, what would angle R be? 85. And that's just because the theorem was able to get it for me. But I could go through this problem other ways. It's just this is the easiest way to do it. So if you ever have a quadrilateral inscribed inside of a circle, the opposite angles are supplementary. Opposite angles are supplementary. Okay, let's look at example 10. It wants me to find the value of x. So let me look at my angle. Is my the vertex of my angle, is it at the center of the circle, on, in, or out? On. So how do I find the angle? Half of the arc. Okay. Do I know what the angle is?
Well, it's 120, it's 60.
Yeah. The angle is 3x minus 3, and I know what you're saying, Austin. And that equals half of the arc. And how much is the arc?
120.
120. Okay. Take a second and solve that for me. Maybe I wanted to draw a stick, Austin Mason. What? Oh, did they actually get put away yesterday? Good job. I didn't realize that you guys had even put them away. I knew the markers and towels got cleaned up. Are we ready?
19. Oh, okay.
Colton Cotton. 21. Now, this problem, I could multiply both sides by 2, but I can just do this real easily. What's half of 120? 60. And so then if I set 3x minus 3 equal to 60, I can add 3 to both sides, which would make 3x is 63, and divide by 3, and that makes 21. Real quick before we go back up to example 8, I want to go back to example 9 and just show you something else. Just to practice something for a second. If this angle right here is 100, can you tell me what's the intercepted arc? In letters. What arc does this one intercept? It intercepts arc RT, right? Because that connects the two sides of the angle together. How many degrees would that arc be?
180.
No, because this isn't a diameter. If that was a diameter, it'd be 180, but that's not a diameter.
260.
So here's my 100-degree angle. It intercepts this arc. What is this arc? Why?
Because if you multiply 100 by 2.
Yes. Haven't we been working with the last couple days that when you have an angle and its vertex is on the circle, when the vertex is on the circle, the angle is what the arc? The angle is half the arc. When we have a vertex of an angle on the circle, the angle is half the arc, right? So if this angle is half the arc and this angle is 100, that means the whole arc must be 200. You okay with that? Okay, I just want to practice another one. Oh, what color can I use? Since you can actually see them. Let's go black. Okay, so what arc does this angle intercept? QS, from all the way from Q to S. So if this is a 95-degree angle, what is arc QS? 190. Okay, so I just wanted to make sure that if you knew the angle, you'll know the arc it intercepts if that angle's vertex is on the circle. because it's half of the arc, so the arc is twice as much. Okay, and let's backtrack to example 8. Example 8 tells us a bunch of things, so I'm going to put it in the picture. It says the measure of angle 1 is 6x plus 11, so I'm going to put the 6x plus 11 in there. It says measure of angle 2 is 9x plus 19, so I'm going to put the 9x plus 19 in there. Measure of angle 3 is 4y minus 25. Measure of angle 4 is 3y minus 9. It tells me that arc PQ is congruent to arc RS, which is important, so I'm going to come back to that in a second. And then it wants me to find all those missing angles, 1, 2, 3, and 4. Okay, this actually goes with that first theorem that we looked at a second ago. This first theorem told us that if we have two angles that intercept the same arc, that those angles are congruent. The theorem also said if we have two inscribed angles that intercept congruent arcs, the angles are congruent. So let's look at this for a second. It tells me that arc PQ is congruent to RS. So angle 3, what arc does it intercept? Angle 3 intercepts arc. Angle 3 intercepts arc what? Okay, I guess you guys you're not getting this. Here's the angle. What arc is in between my markers?
PQ.
PQ. Right? Angle 3 intercepts arc PQ. Okay, let me look at angle 4. Angle 4 intercepts arc RS. Angle 4 intercepts arc RS because that's the arc that's in between the markers. Okay, so didn't the problem tell us that these two arcs were congruent? So the theorem on the previous page said if we have two inscribed angles that intercept either the same arc or they intercept congruent arcs, then the angles are congruent. Let me show you the words again. Here it says, if we have two inscribed angles that intercept congruent arcs or the same arc, then the angles are congruent. So flipping back. Do you agree that this inscribed angle and this inscribed angle, they intercept congruent arcs? So I know my angles are congruent. So I know that angle 3 is congruent to angle 4. If those two angles are congruent, what would your equation be? Three y minus 9 is equal to 4y minus 25. If angle 3 is congruent to angle 4, then 3y minus 9 equals 4y minus 25. Take a second and solve that for me. You have it already?
I think so.
Okay, just a second.
It's in my brain.
I got it.
Okay. Austin, go ahead. What'd you get for y? 16. Do I need to actually work it out for anybody?
No.
Okay, so let's figure out angle 3 and angle 4. How would I figure out what angle 4 is?
Plug in the Y.
Yeah, plug the 16 into the y. Okay, so take 3 times 16 minus 9. 3 times 16 minus 9.
30.
3 times 16 minus 9.
39.
39. If angle 3 is 39, what's angle 4? 39. I don't even need to do the math because I know those two angles are congruent because those two angles intercepted congruent arcs. Okay, and then let's look at this bottom one for a second. A little bit ago we learned that if we have an angle that intercepts a semicircle, would you say that angle T down here, that it intercepts a semicircle?
Yes.
What did we learn about angle T? It's 90 degrees, right? It'd be half of the 180 and half of 180 is 90. So what kind of a shape do you have down here?
A right triangle.
And so how could I set up an equation to solve for x if I know that this is a triangle? No, no, no.
6x plus
These are
11 plus 9x plus 12, 19 equals 180.
So this plus this equals 180. 6x plus 11 plus 9x plus 19 plus the 90 all add to be 180. It's a triangle, right? And we know our three angles in a triangle add to be 180. Okay, I'm not going to take time to solve that because I want to go ahead and take our quiz. All right, if you guys could, you can have your note card out. You can have your note card out. And if you could go to rows. Oh, and before you do that, I did want to give you an assignment tonight. Sorry. Okay, so tonight, I want you to do page 15, but you can cross off number 13. So page 15, and you can cross off number 13. So page 15, you can cross off number 13, and if you guys can go to rows, and you can have your note cards out, that's fine. Let's do it.
I haven't seen it.
So page 15, and you can cross off number 13. It shouldn't be too time consuming. No, it shouldn't be. 5.
Oh, wow.
It's like red.